We introduce Archon, a unified multimodal model for holistic digital human generation. So, what is Archon? Archon enable any modality to any modality generation across 7 modalities. For example, we provide a textual description and spoken script of the person. Archon then generates synchronized animation, semantic video, and the final video with audio.
That if you are a new fan to Quatrains, that you can be a new.
The direction can also be reversed. From a silent video, Archon can infer the description, recover the animation, and synthesize synchronized speech.
With itself, with sound tells with the P from the wrists. And similar.
Archon also supports editing.
These are algorithms' uncanny ability to specifically classify the human.
Here, we keep the scene and person's identity and voice, but change the spoken script.
It just was at a standstill after a while. There wasn't really much evidence.
Beyond generation and editing, Archon supports more than 70 multimodal tasks, including video generation, image generation, animation generation, multimodal editing, speech generation, multimodal understanding, script recognition. This motivation comes from recent multimodal language models, which already show strong reasoning ability between text and images. The next question is, can we unify more modalities into a single multimodal model, which naturally exist in digital humans? To achieve any-to-any generation, existing systems often combine multiple expert models. However, this creates fragmentation. Our goal is to build one model that maps from any set of modalities to any other set of modalities. Existing literature still lacks methods that fully satisfy this goal. Vision language models can understand multimodal inputs, but their outputs are usually limited to text. Unified visual generation models can produce images or videos, but they usually do not model speech audio. Other unified models exist, but their audio reasoning or audiovisual quality is still insufficient for high-fidelity digital humans. To fulfill this goal, we face 3 core challenges. The first is any-to-any multimodal modeling. How can we fuse multiple modalities into one unified model while enabling flexible any-to-any generation? The second challenge is video tokenization. High frame rate talking videos produce too many tokens, so we need an efficient way to tokenize continuous video signals without exceeding the context limit. The third challenge is reliable cross-modal generation. Tasks such as speech to video are highly ambiguous, so we need to reduce uncertainty and improve generation quality. Archon addresses these challenges with shared discrete tokens, unified multimodal AR model with 72 training tasks, efficient semantic video representation and diffusion decoding, and a thinking in modality strategy for reliable chains of modalities. Now, we introduce the model pipeline. First, each modality is tokenized into discrete tokens to form a unified multimodal token space. These include off-the-shelf tokenizers for common modalities, such as text, audio, and video, as well as our learned tokenizers for specialized modalities, such as animation and semantic video. Instead of using many special task tokens, we use a structured prompt in a JSON-like format to describe the inputs and the requested output. For example, the input uses natural language as the key and modality tokens as the value, while the output key defines the target modality to be generated. With this design, the model supports multiple multimodal tasks in a clear and uniform format and generate any modality conditioning on previous results. Then, the language model performs multimodal reasoning over this unified token sequence. The generated tokens are detokenized back into their native modalities. However, this raises an important question: how should we process the video modality efficiently? Video is the hardest modality.
Yacht, and I was supposed to basically throw this.
A 5-second talking video at 30 frames per second can require about 9,000 tokens, which exceeds an 8K context window. Moreover, direct RGB tokenization can damage the continuous visual quality of video. To solve this, we reparameterize video into a semantic video and a reference image. RGB video is continuous and token-heavy, requiring around 9,000 tokens. Compared with the continuous video signal, semantic video uses discrete labels from 0 to 20 and only needs around 2,300 tokens. This gives roughly a 4 times token reduction. We can discretize a video using an off-the-shelf segmentation model and first frame extraction. The reverse question is, how do we convert the semantic video and reference image back into a high-quality video? For text-to-video generation, the multimodal model predicts compact semantic and appearance conditions. Then, we design a semantic-driven diffusion decoder to generate the final video using semantic motion and reference appearance. Some cross-modality transitions are still difficult, which leads unstable identities generation or visual artifacts.
The director of the film that I'm going to talk about tonight, Split, M. Night Shyamalan, saw...
Okay, today's tip is for you if you want to know how to get more auditions from your submission.
This motivates an inference time strategy that benefits directly from our unified model. We call this strategy thinking in modality. The model reasons through a new chain of modalities. It can first go from speech to description, then use the description to generate an image, then use all previous modalities to generate animation, semantic video, and finally RGB video.
The director of the film that I'm going to talk about tonight, Split, M. Night Shyamalan, saw that going...
Okay, today's tip is for you if you want to know how to get more auditions from your submissions.
These intermediate modalities reduce uncertainty and make the generation process more controllable. Next, we evaluate Archon on multimodal generation ability. First, we compare with expert models on speech-driven image animation, including UniPortrait, EchoMimic, and Hello 3. Archon achieves the best FID and FVD on both Celeb VHQ and HDTF, showing stronger video quality. Qualitatively, Archon preserves identity and produces synchronized mouth motion under challenging expressions.
I represent Florida's 27th congressional district.
Yacht, and I was supposed to basically throw this big sex orgy thing on.
This shows that unified multimodal training can remain competitive with, and sometimes outperform, specialized experts. For image-conditioned text-to-speech, Archon improves image-text similarity and identity accuracy while remaining close in audio fidelity. For human video understanding, we compare with a multimodal language model. Archon reaches a comparable F1 score to Quanomni, a 30B model. Finally, we compare with NextGPT, a unified multimodal model with the closest modality range to ours. The task is text-to-audio video generation from detailed human descriptions. The baseline captures some high-level intent, but its generated audiovisual quality and human fidelity are limited.
And there are people who say there's no such thing as a bad audience.
That if you are a new fan to Quatrains, that you can be a new...
Archon generates a more coherent talking human video with better prompt alignment and synchronized speech. Please visit our project page for more results. Thanks for watching.